Hello, welcome to the third week of this massive open online course, Introduction to PLSQL Program Units. You are viewing the third video of this week, Working with PLSQL Packages. After gaining knowledge about PLSQL packages, Jill decides to group the standalone procedures and functions in her application into relevant packages. She starts this task by creating a package that handles departments' data. In this package, she includes procedures to add a new department, modify the details of an existing department, and to remove a department from the organization. All these procedures will be public and act as an application programming interface or API. Before a new department is inserted or an existing department is updated, the input values are validated. The validation rules are not made public and are managed using a private function in the package body. Let's try creating this package for Jill. As a first step, you have to create the package specification. Let's create the package named dept_pkg using the create or replace package statement. By using the replace keyword, if a package with the same name exists, it will be replaced with this code. The replace keyword is optional. Then declare the public procedures add_dept, upd_dept, and del_dept in the package specification. Let's not declare the function validate_loc to validate input values in the package specification. We will create it as a private function within the package body because we want it to be accessible from only within the package. Note that the package specification must contain only headings of the public procedures terminated by a semicolon without the is or as keyword and its PLSQL block. The implementation of a procedure or function that is declared in a package specification is done in the package body. After you compile this code, the package specification gets stored in your schema as dept_pkg. As a next step, you have to create the package body to define and implement all public subprograms and supporting private constructs. You can create the package body using the create or replace package body statement. In this package body, you have to provide the implementation detail for all the three public procedures declared in the package specification. There is no restriction on the order in which the procedures are defined. The basic principle is that you must declare a variable or subprogram before it can be referenced by other components in the same package body. It's a common practice to define all private variables and subprograms at the beginning and the public subprograms at the end of a package body. Let's start with defining the private function to validate the location ID of a department. The function validate_loc takes the location ID as input parameter and returns either true or false based on the validation. Now, let's define all the three public procedures one after another. The add_dept procedure takes new department details as input parameters. It first validates the input location ID by invoking the private function validate_loc. Only if the location is valid, the new department row is inserted into the departments table. The upd_dept procedure takes the new location ID and the department ID of the record to be modified as input parameters. This procedure also invokes the validate_loc function to validate the new location ID before updating it in the database. Finally, you have to provide the implementation detail for the del_dept procedure. This procedure takes department ID as input parameter and deletes the corresponding row from the departments table. Let us execute the script to create the package body. Notice that the dept_pkg body appears in the connections tree now. To invoke the subprograms defined in a package, you have to qualify them with a package name. For example, to invoke the procedure del underscore dept, you can use dept underscore pkg dot del underscore dept from a PLSQL block. However, you can execute the package subprograms from SQL Star Plus or SQL Developer directly by using the execute statement as shown on the screen. Let us execute the procedures defined in the dept-pkg package and analyze the results. Before executing the add underscore dept procedure from the package, the maximum department ID in the HR database was 270. Executing add underscore dept inserted a new department row with department ID 280. Executing upd underscore dept procedure from the package successfully updated the new record's location ID from 1000 to 1400. Finally, the del dept with parameter 280 successfully removed the corresponding row from the departments table. As you know, the variables and constants declared within standalone subprograms exist only for the duration that the subprogram executes. What if you want to declare global variables or exceptions so that they can be used across the application subprograms? To achieve this, you can create a package that has only the package specification. You can declare all the public or global variables, exceptions, and constants in the package specification. As there is no need to create a body for such packages, they are called bodiless packages. For example, Jill can create a bodiless package called user underscore exceptions underscore pkg with all the user defined exceptions used in this application. She can then use these global exception variables in any subprogram by qualifying the exception with the package name as shown on the screen. Even though the exception e underscore salary underscore out of range is not declared in this program, it raises the exception successfully when executed. You can query the user underscore source or all underscore source data dictionary views to view the package details. Use the user underscore source view to display PL/SQL code that you own. You can view the source code of the package specification as well as the package body for the packages that you own. Query the all underscore source view to display PL/SQL code of the package specification of the packages to which you have been granted the execute right by its owner. While querying these views, use type is equal to package to display the source code for the package specification and type is equal to package body to display the source code for the package body. When a package is no longer required, you can use the drop package statement to remove it. Since a package has two parts, you can either remove the whole package or remove only the package body retaining its specification. This video demonstrated how to create a simple package with public and private constructs. You learn how to invoke public and private subprograms of a package. You also learn what a bodiless package is and where is it applicable. Finally, you gain knowledge about using data dictionaries to view package information. To practice what you learned, solve the assignment posted for this video on the OLL course page. Post your questions if any in the course forum whose link is shown here. Thank you for watching this video. Have a great day.